We turn now our attention to how research infrastructures will address climate challenges over the next 30 years, which I used to think 30 years was a long time. Like people would say, oh, in the next 20 years, the next 30 years, it always seemed like forever. It stopped feeling like that. I don't know what point. At some point, I crossed the line and it seemed like it's tomorrow. So I hope this panel is going to fix everything for us because, I'm certainly not going to. The panel will be led by Michael SanClements. From 2015 to 2022, Mike led the US National Ecological Observatory Network Terrestrial Instrument Science Team. I got most of that right. Currently, he's the Research Initiatives Lead for Battelle, where he serves as Principal Investigator of a National Science Foundation award to harmonize global data from research institutions. For the first time today, will you please put your hands together and welcome to the stage, Mike SanClements.
Good morning, everyone. I'm excited to be here today and thankful for the opportunity to moderate this panel of excellent speakers from around the globe. Today, we're going to discuss how global research infrastructures address climate challenges through monitoring, mitigation, adaptation, and support for decision makers. And a critical issue to explore here is the delineation between enabling research and operational monitoring, and what are the best practices for interagency cooperation to bridge existing gaps in geography and culture. Having been involved in leadership roles in the NEON research infrastructure since completing my postdoctoral position in the Antarctic McMurdo LTR network in 2012, and now serving as lead PI for an NSF CellNet award targeting harmonization of data and growth of collaborations across the Jerry Group research infrastructures in the US, South Africa, China, Europe, as well as here in Australia. The ability of RI is to balance enabling research while providing high quality monitoring data is a topic I see as central to our success. I'm also excited to hear from our panelists on how we navigate best practices for interagency collaboration to fill critical global gaps and perspectives from underrepresented regions. And with that, I'd like to call the panelists to the stage, and we'll proceed with some presentations and then discussion. Our first speaker today will be Patricia Nyingiro, a climate scientist and researcher working at the Kenya Meteorological Department of the Climate Change Branch. She's also the IPCC focal point for Kenya, and she works at the Science Policy Interface, making science and research actionable and relevant for implementation and development policies. Patricia, thank you.
Good morning. Indeed, the jet lag is worth it. So this is my first ICRI or ICRI conference. And to be very honest, it's been very interesting to sit in rooms and listen to what global and regional and national research infrastructures are doing. And particularly for me with interest in climate change, this is has been also very interesting. I don't know if I can, have my slides up, please. All right. So my perspectives that I share with you with respect to how research infrastructure can support climate change response over the next 30 years is based on my work in Africa and in Kenya, but also at the interface of science and policy. So for many developing countries, well, it looks like I have to figure out how to... Yeah. All right, there we go. So for many developing countries, and particularly those ones that are tagged as vulnerable, adaptation is actually the priority. But for many, for responses, most people would focus on mitigation, which is a lot of what we see across the globe. And we recognize that even as much as adaptation is a priority for our regions, we have global obligations because climate change is affecting everyone. So having said that adaptation is a priority, how can we then use research infrastructures to be able to support climate change responses in that field? So to answer this question, I'd like to share a little bit about some of the work that I am currently doing or is in the works for us. And one is an EU funded project that is called CADI. And the aim of CADI is actually to build a comprehensive concept for an African research infrastructure. So I've put GHG observations in bracket there because when we were developing this or writing the concept for this project, this was the initial plan to actually do this for greenhouse gas observations. But from interactions with our users and our perspective as my perspective coming from an operational background, we found out that heat is actually an urgent need. In Kenya and Africa, and a lot of African countries actually, perceptions of heat are very low. And we experience heat waves with impacts on health, but these are not documented anywhere. Across the continent, very few countries, and particularly in South Africa, there is a lot of research on heat, but in Kenya and a lot of other African countries, there is very little research on heat. So this proved to be a more pressing need than greenhouse gas observation. So we developed a pilot in Kenya on urban heat and particularly focusing on informal settlements. And then this moves right into locally driven research and community involvement. So we were able to work directly with informal settlements, community members from informal settlements, to help us understand how they sense heat. So as a provider of climate information, we would give them what temperatures we expect for a coming season or a coming day. And we would have no idea about how this temperature directly impacts them. And so we carried out research to find out how do these heat, what thresholds exist for them to experience detrimental health impacts. And so this underlined for us the fact that actually research infrastructure need to include communities themselves. Additionally, there is work that we have been doing with smallholder farmers as part of the Adaptation Research Alliance. And this came up from the need to understand what do smallholder farmers experience in terms of climate change and how are they coping. So in Kenya, the Kenyan Constitution does not recognize indigenous knowledge, but terms it traditional or local knowledge. And so our aim with this particular project was to look at how smallholder farmers experience climate change and what they're doing to cope with it, and therefore to design adaptation research to address the needs that they have. And before I talk about the IPCC, which is the next one, this led me to led us to think about how do we compose research infrastructures in the current world today. And so to be able to cater for the socioeconomic impacts that climate change has on people, it is imperative that we include not just data providers, researchers, and scientists, but also policy makers, local government, and community members, health practitioners, for example, if we are looking to develop heat action plans for cities, and this therefore becomes more and more important as we go into the future. So research infrastructures need to increase in their composition to take into account local community members and policymakers who make the decisions that will impact the people. Now on to the IPCC. So as part of my role, I am responsible for knowing what kind of research is in the region or in the country that can serve as input for the assessments of the IPCC. And this brings me to this very interesting figure that was in the Working Group 1 report that was recently released in the AR6. And unfortunately, as you can see, there is a dearth of data, particularly in the global south. And what does this mean for us? This means then that we cannot design climate services in a way that is adequate because we do not have enough data or observations. But it also means that we are not able to generate projections to be able to develop climate change adaptation actions because we have very little information. And for me, this is more of an ethical issue that needs to be addressed by research infrastructures now and going into the future. To further illustrate that, I have this figure that comes from WMO and the WIGOS data quality monitoring system. And as you can see in the global south, again, we have a lot of black dots, which there shows that data has not been received over a long period of time. And so this has impacts on both operations and on research, because if we are to develop, for example, projections of climate change for applications in various sectors, and we have very minimal data, then it means then that we do not have accurate information to act upon. And it might look like it is a global south problem, but for global infrastructures, we need information that is robust from across the globe to be able to develop collaborative systems that enable us to cope with climate change. And so, ethical considerations. So I thought I would put this slide in here. We've talked a little bit about environmental considerations of research infrastructures, and we've teased a little about ethical considerations. And so this is just something off the top of my head and some from discussions I've had with colleagues. So for example, there is one country in the EU that has more G-borne compliance stations than the whole of Africa combined. And for me, I think that's immoral, almost. There is also the question around do we have adequate representation in research infrastructures, particularly global research infrastructures? Also, do we incorporate locally led adaptation research for both an operational and community perspectives? As well as the fact that when we are carrying out research, and I really like that yesterday we had a conversation around the difference between methods and methodology. When carrying out research, how do we treat vulnerability? How does that impact how we carry out research? So for example, can we delineate the drivers of natural variability versus the vulnerability as driven by colonialism and past and ongoing economic exploitation? And growing scientists, the nice video that we watched yesterday brings up the issues of intergenerational ethics. To what extent do we address climate change now, and to what extent do we leave this challenge for the future? Finally, I picked this very interesting graph from a presentation yesterday. And for me, it really made me think a lot. And so the question I raise here is, so the IPCC says that we can achieve universal energy access without increasing greenhouse gas emissions. And yet, for the global south, and particularly for Africa, very few countries have access to energy. And so the question is, how do we balance the increasing energy needs, as has been very clearly outlined, for AI and machine learning, and universal energy access? Where's the ethics there? What do we prioritize? And so with that, I think I can leave you thinking about that. Thank you.
Thank you so much, Patricia. Our next speaker will be Professor Sushil Kumar, and he's the Director of Research at the University of the South Pacific in Fiji. He's an accomplished researcher and educator who has spent more than 30 years working across climate change impacts, natural hazards, and sustainability. Professor Kumar has more than 15 years of administrative experience, including as Associate Dean, Research and Graduate Affairs, and Director of Research. Sushil?
Thank you. Good morning, and Yandra in the local Fijian language. I would like to present the South Pacific perspective over the issue which we are discussing. And in the South Pacific region, there's a university called the University of the South Pacific, which was established in 1968. It has got, it's owned by 12 island countries. It has got 14 campuses in 12 island countries. And at a regional level, we have got the 2050 strategy for the Blue Pacific continent, and it has got own vision, which you can read from there. It is to build the resilient and peaceful South Pacific region. There is a threat of the climate change, which we will talk a bit more. This is a bit of the information about how this strategy came into the place, discussed and decided by the 18 member countries. This is where the impacts of the climate change, ocean and land-based environment degradation, they are the prime topics to address. But then the region has got some advantages of being a lot of young population. In the Pacific region, mainly the countries are the coastal countries, where about even up to 100% of the community depends upon the coastal resources. Globally, about 40% population depends on the coastal areas, but the South Pacific region is bit different than that. In terms of the blue economy, it depends primarily upon the fisheries, aquaculture, tourism, marine transportation, renewable energy, and biotechnology, which is actually an opportunity yet has not been exploited. The strategy actually identifies the strategic research themes, which you can see from there. There are the 7 strategic research themes in which the climate change and disasters, ocean and environment are highly relevant to the coastal communities. Apart from that, the others are there. Just to show that under the research infrastructures, what is normally the research offices are supposed to do is to get the external grants, is to get the quality publications, and then increase the impact of the research in terms of the citation and then the social impact. And the next one shows that what is the expectation of the academic staff from the research office is almost the same priorities. As I have said that this is the region which is most impacted by the climate change, and the 2 of them are the sea level rise and the natural hazards happening because of the climate change, particularly the tropical cyclones. You can see the different scenarios of the sea level rise, and with respect to some of the countries, you can see the Tonga, Kiribati, and Tuvalu, the small countries. And I give you a couple of pictures how these islands are affected under normal conditions. This is Kiribati, which is low-lying country. Under the normal tide conditions, the ocean water can inundate into the region and can disturb the fresh water. There is hardly any fresh water. It all depends upon the water which we get from outside. This analysis bit shows that how the tropical cyclone frequency, which is one of the most dangerous natural hazard for the South Pacific region, has been changing. Overall, there is no change in the numbers, but if you look at the table number 2, this is where the frequency of the strong tropical cyclones is increasing, which is quite detrimental. And here are a couple of more pictures of these low-lying islands. You can see that they are almost at the level of sea. And you can see a couple of more. Tuvalu, which you might have heard at a international level, the country which is getting under the water because of sea level rise slowly, and some other countries' pictures. And here is what are mainly the impacts, the sea level rise and extreme weather conditions. And some of the actions which are needed to address in terms of the mitigation and then the adaptation strategies. What we need here is we need the infrastructure which is resilient to the natural hazards coming out because of the climate impacts, and then the strategies according to that. The South Pacific region has got some limitations, for example, like human resource capacity, and there's a migration of this. And there is this natural hazards. There are small economies. Because of this, the region is not very strong in the research infrastructures. It all depends primarily what we get from external fundings. I think this is where there is a strong need of the partnerships and then the collaborations and networks. And I urge you guys, look at building the strong collaborations with the South Pacific countries, because these are the countries which need collaborations, fundings, and then the partnerships. With this, thank you very much. And in my local language, Vinakabaka Lebu, thank you very much.
Thank you, Sushil. Our next speaker will be Matthias Troncaso. And speaking of jet lag, I think he might win. He was on holiday in Italy and flew home to Cape Horn and then flew back here, arriving yesterday. So he might, he's probably ahead of us all in the jet lag department. And Matthias is the local coordinator of the Cape Horn LTR network. And at the Cape Horn International Center, he serves as a geophysicist responsible for managing the monitoring system of climate, ecological, and physiochemical characteristics in the subantarctic Cape Horn Biosphere Reserve in Chile. His work involves fostering collaboration between public and private organizations, including the Chilean Navy, the Ministry of Environment, and the Ministry of Science of Chile, as well as various NGOs. Matthias?
Hi. Hi. Hello, everyone. First of all, thank you so much for the invitation. It's my first time here in Australia. It is actually a big jet lag, but it's okay. I think I like it, even though it was hard to be awake yesterday and hard to be sleeping this night, but it's okay. Well, yes, my name is Matías Troncoso, Matthias, Matthias. I have heard a lot of names, it's okay. First of all, well, northern and southern hemisphere are different. It is quite evident, but sometimes it is forgotten. Northern hemisphere, just forget one main difference is huge and land biased, and southern hemisphere is ocean biased. You can see there's a line. If you make a line of latitude around 60 or 40 degrees, it is roughly 50% land and 50% ocean. But if we do the same at the same latitude in southern hemisphere, is 98% ocean and just 2% land. Well, if you go just a bit southern in the south, it is 100% ocean, because you have the circumpolar current, Antarctic circumpolar current, and well, it makes a big difference. You can see there in the Bonanza Creek LTR site, you have a tremendous continental difference with the temperatures and temperature amplitude range about the year is quite high. But in the southern, we do not have that, at least in the coastal areas, and well, most of it is coastal area. South there, you can see Omora Park, meteorological weather station. The lines are through the year almost the same. The temperatures in summer are by average 9 degrees. Today it was 6 degrees. I look at it. And in the winter, it is maybe 5. So it is not a big difference throughout the year. It is a main difference between northern and southern hemisphere. And well, that carries us to where I work and live. I live there where the heart is. This is the heart is actually my home. You can see I put there some latitude lines. We are now at I think 27 degrees south. It's northern Chile, Copiapó, it's the same, but where I live is 55 degrees south. It's like in the northern hemisphere, being in Edmonton, Alberta, being in Berlin. I think London is quite around there. And you can see that it is not comparable. You know, in Berlin you have maybe warm summers, cold winters, real cold winters, and we do not have that. That's one way of seeing it. Well, crossing all this ocean, I'd like to have taken the direct flight that exists, but no, I had to go all the other way. Okay. Well, you can see we're real close to Antarctica. We're the closest place to Antarctica outside of Antarctica. It is only separated by the Drake Passage. The Drake Passage is roughly 1,800 kilometers wide in that place, and that's why we call ourselves a subantarctic territory. Even though we are not quite familiar with what you might expect as subantarctic, like that's like maybe tundra, we do have big forests, and that's some difference that I can talk about. This is the following difference between northern and southern hemisphere, and it is research. You can see here with clusters a screenshot that I talk about the ELTR sites, the International Long-Term Ecological Research Networks sites. You can see big cluster there in Europe. It's 540. Where I live, there's 3. And you can see that in April 2011, in the left figure, in our place that didn't exist yet. It was 0% representative in that band of latitude. Today we have 6 sites, of which we manage 4 of those in that wide of latitude. But you can see that the difference in the northern is actually bigger. Right now there is 65, that 6% of the sites are in the band of 60 to 40 degrees north, and 13 years ago it was 65, that's 0, so it is growing. And this is the Magellanic Subantarctic region that I was talking about. That's the island where I live. There is Navarino Island. It's quite similar to a bear, but we have no bear, so that's why it's prohibited. Don't think about a bear. This region is the green part. It's the western part of southern Patagonia, also called, but we are different to what you can expect of Patagonia. Also, that's big landscapes of maybe dry pampa. We do not. We are in fjords, immersed in big forests and glaciers. And in that same, we can see here the reserve in which I work. It's Biosphere Reserve, Cape Horn Biosphere Reserve, and the marine park that's created. It is the biggest research protected area in Chile. It's roughly touching the 60 degrees south because of the Antarctic Treaty. So it's 59.9. In that place, we built, it should have been an animation, but it's okay. That's our new headquarters. That's Cape Horn Subantarctic Center, in which I work. You can see an amazing architecture. And the town where we're located is Puerto Williams. That whole map is Puerto Williams, and the blue square is our building. So it is quite imponent, you can say, but because of the architecture, it is not a gigantic building, but it is camouflaged between the environment. In that place, we do have laboratories. This was finished 2022, so we are starting with it. We are with, you can see in the first slide, a wet laboratory where you work with maybe incubators, ovens, and freshwater insects. In the second, it is the molecular laboratory for diseases, malaria, avian malaria. Afterwards, you can see we have an auditorium, this one. It is widely used in the town. The municipality asks a lot for it. We also for parties. I remember when the kindergarten was graduating, they were like crazy. We stopped working that day. So, but it's okay. We like to do that kind of thing, and it is quite amazing because 10 years ago in Puerto Williams we didn't have internet, and now we have optic fiber, and it's a 6 terabyte. Why it's not the 10 terabyte that you have in Western Australia, but it's for 2,000 people. I think it's okay. And we also, you can see, are imparting our recent career. It's tourism in biocultural conservation. It is not tourism of adventures, but for conservation and why that can be a touristic approach to the place. Like to take care of the ecological and not to use it. And just to finish, we divided the reserve in different areas because those are the real different between all of those. And we have a strengthening network of monitoring, including mainly weather stations, but also ecological. We have eddy covariance towers. We have Motus monitoring, bird monitoring system. It's quite amazing. That's my main job. That's what I like to do, the expeditions. Once we had a 10-day expedition that was not that well, but I like it anyway. I think that I have passed my time, but we have some research, and then we can afterwards in the questions explain. Well, that's it. We're in the south and going southwards also.
Thank you so much. And next up is Werner Kutsch, Director of the Integrated Carbon Observation System, or ICOS, in Finland. Werner?
Yes, thank you very much. My name is Werner Kutsch. I am, by education, an ecosystem scientist, and I worked on the carbon cycle of ecosystems and the adaptation and in ecosystems and also in complex landscapes in Africa and in Europe. And I think it's fantastic to understand the mechanisms that allow ecosystems to cover our planet from the frozen poles to the hot tropics. So as a scientist, I worked on EI, not on AI, on EI, evolutionary intelligence. And in the last session yesterday in the evening, we saw a fantastic example of evolutionary intelligence, because the best model for an optical sensor for a satellite was the eye of a lobster. Well, down here on Earth, we are doing our best that lobster become extincted. The reason for that is the atmospheric perturbance of the natural carbon cycle. And before I give you my 3 thoughts, I would like to go 30 years back, because the title of this session is to go 30 years, to look 30 years forward. 30 years back, roughly 30 years ago, we had the publication of the second IPCC report, and the message was we have to get away from fossil fuel emissions. During these 30 years, fossil fuel emissions have been increased by 60%. So that's not what you call a success story. And the catastrophic impact becomes more and more visible as we are starting to hit to 1.5 degrees of increase in global temperature. Since 10 years, about 10 years, we are working with scenarios. They are called the socio-economic pathways connecting the emissions to the resulting temperature increase. So you can see in this graph that the next 30 years decide between carbon neutrality in the year 2050 or shortly after that, and the limitation to about 1.5 degrees temperature increase, or in the most pessimistic scenario, the doubling of the emissions and an increase of the global temperature of almost 5 degrees. The trend of the last 30 years predicted in the next 30 years may be a 60% increase, and this would bring us to a 4 degrees world, a plus 4 degrees world, and believe me, you don't want to live there. So there is a huge political uncertainty when we are talking about addressing the next 30 years of research infrastructures dealing with climate change. Nevertheless, I would like to give you my 3 thoughts. The first thought is it only works together. We need multilateral cooperation in science, and this supports, of course, the multilateral cooperation in climate politics. It has been shown many times that scientists working globally together can have a huge impact on the political agenda. Climate science is a powerful example. Climate science has set the agenda for fading out fossil fuels and for decarbonization of our societies, and it has done it through multilateral cooperation. And even though multilateralism is under pressure by nationalistic movements nowadays, we should increase our global cooperation. On the ground, this cooperation in terms of research infrastructure has a lot of laborious things like standardization, data curation, but also scientific exchange and cooperation in the data analysis. And I think that's really important, and we really should strengthen the IPCC as a collaborative tool It has just started its seventh assessment report, assessment cycle, and there are thousands of scientists working together on the next reports, and the research infrastructure we should, as research infrastructure, we should support this work. I think we should see the IPCC as our natural stakeholder. ICOS is an example for a multilateral research infrastructure combining 16 European countries and providing a distributed observational network over Europe on greenhouse gas concentrations in the atmosphere, fluxes on greenhouse gases between land and oceans and the atmosphere and back. However, we also want to support our African colleagues, and the CADI project was already mentioned, and we want there to design the best available infrastructure that we hopefully then can also implement during the next years. You can see here that with a few atmospheric stations more, we can cover the African continent, and we can also then see the African fluxes much better represented in global modeling. So supporting our African colleagues in doing this work is also another example of multilateralism. My second thought is it's about excellence. We need the best available science. Only excellence brings us forward, but best available science is more than only scientific excellence. It's timely data, because we want to support the political processes, and it should describe the success of climate action. So the data should be usable by our societies to see the success of climate action. And we should definitely connect social and environmental research, but we should even go further. Each of the domains sitting here should contemplate how it can contribute to the decarbonization solutions. And this is much more than putting solar panels on the roof of an accelerator or painting a telescope green. We need all domains to contribute. In our annual work plan for the next year, or in your annual work plan for the next year, every domain, you should have a chapter, what will be our scientific contribution to solve the climate crisis. And well, I got some ideas, or we got some ideas in the session 2 yesterday, and I'm very grateful that we had this session, because this was going through all the different domains. Finally, I have a third thought, and I expect that half of the people in the audience will throw rotten tomatoes on me when but I brought my umbrella, and I will say it anyway. We have to talk about money, of course. And it is a fact that research infrastructures addressing climate or other environmental changes are very often not financially sustainable. And I think that's a situation that we can't accept. So when it comes to resource distribution, we might rethink where we put our money. And I have 2 thoughts for you. I think fusion will not come in time. We are always promised to have a fusion reactor in 30 years, but it's continuing to be in 30 years. So in the next 30 years, we will not have a practical fusion reactor. Why putting money when we have urgencies and when we have a perfectly functioning fusion reactor nearby? This fusion reactor is called the sun. And it's providing us with 1,361 watts per square meter constantly. The problem is only how to collect this, and we should concentrate our research on harvesting this energy and storing it. And by the way, this is a problem that the evolutionary intelligence has solved about 3.2 billion years ago by inventing a process called the photosynthesis. So I also think we don't need the next generation of CERN now. I think this can wait for some 30 years, and we should put money into the urgencies. Thank you for your attention.
Thank you, Vern. We have a few moments for discussions. And so one of the things I recognized and heard throughout these different presentations was that we have shared large global environmental challenges, and we also all have our unique local environmental challenges and networks and infrastructures. And so, Sushil, I would like to get some insight from you on what you think is the best way to go about balancing these global and regional scientific priorities for research infrastructures.
Thank you. I think it's a good question. If we look at, we have to look at the United Nations Sustainable Development Goals. I think that is our archive aim, and to me, both the regional and the global, the researches are aligned to these goals, particularly from the climate action point of view. And what we will do at a regional level, it all depends upon what are the needs and aspirations of those communities, and what are the important areas. Means, for example, like the landlocked country will have the different research priorities than the coastal countries like the South Pacific small island countries, for which this sea level rise and then the natural hazards associated with the climate change impacts are the priorities, and then the life under the water is the priority. Whereas if you look at a global scale, the living in the changing environment, health and well-being, food and water systems, economy and technological growth are common at a global level. They do also apply for the regional level, but the different regions have got different particular priorities. For example, like South Pacific region has got what I have said a couple of times, sea level rise, and then the coastal erosion, coastal inundation, and the life below the water. Thank you.
Great. Thank you, Sushil. Does anyone else want to chime in on that question, or I could move on to others? Patricia, one of the things you brought up was sort of this idea of balancing that research and operations for these research infrastructures. And how do you think it's best balanced? And when we consider the number of research infrastructures out there, do you, in your mind, think there's sort of a one-size-fits-all approach to that, or do you think it's unique to each culture and infrastructure?
So I would say it's not a one-size-fits-all. It's unique for every research infrastructure. But I will also say that enabling research and maintaining operations are both crucial elements of research infrastructures. But from my perspective of working in an operational center, I feel that operations have greater impact. And so if we can design research to solve the questions that operational centers have that serve the users, then it leads to greater impact.
Great, thank you. Anyone else with that? Werner, I have a question for you about, you mentioned a number of different places around the world as well as ICOS, and what do you see as some of the largest challenges to this interagency and intergovernmental collaboration and coordination? And I know as part of JRE, that's near and dear to your heart as well.
No, I think the glass is half full, I would say. It's that we have all this wonderful cooperation. We have started also recently, far too late, the cooperation between Global North and Global South. We have in Europe the cooperation between the different research infrastructures on the environmental, in the environmental domain, the so-called ENVI community. We have the JRE, so we have started with the cooperation. We have done a lot in standardization, for example. We are working on global data sets, for example, for fluxes, for atmospheric concentrations, and so on and so on. So it's going on, but of course there are always these little egoisms, and that makes things sometimes difficult to come to a real cooperation. We should really think more about the community, and we should think less about the advantage of our own research infrastructure. which is difficult because we are in a way also competing about money, but I think being stronger, we will be stronger as a community, and that's what we should take away here from this meeting, that there are so many opportunities to cooperate for a better, that we should really think how we can improve that.
Great, thank you, Werner. And I wanted to get one more quick question in from Matthias. Matthias, we talked a little bit about yesterday in chatting sort of this idea of, is there parallels and are there collaborations that can be founded between the North and South with regards to the spread of tropical diseases in both directions, and if right now we're doing a sufficient job of that and what we could learn from each other. And I'd love to hear your perspective on that.
Yes, yes, that's very, very interesting. Since we are state-funded in both ways, the building was funded by the state of Chile, and the working of it is also funded by the Ministry of Science, but it is a way from the Ministry of Science that's aiming not to science itself, but for transference to the society. So in that sense, we do see that connections between northern and southern hemisphere in terms of main diseases is quite evident. In that same way, we are working with long distance migratory birds, mainly because those are vectors or carry themselves vectors of diseases, avian malaria and avian influenza. We're working with Motus system, which is the improvement of the ancient way of going to the field and tracking your animal, your individual. Motus is a fixed station that follows every animal or whatever you want to follow 24 hours, the whole day. So it allows us to identify the pathways of birds that in the Americas are mainly two, the Pacific pathways and the Atlantic pathway of flyway, I mean. And we have discovered that birds that breed in the Cape Horn Biosphere Reserve in the southern tip of the Americas fly to Alaska and to Hudson Bay in Canada. So it is a long way. We have to identify the sites in which they stop, the stop sites, and the intermediate breeding sites that there is, following what species we're following on. Maybe in the Amazonas we identify a little sparrow that breeds in the Amazonas, and coastal birds in the northern hemisphere. I think that's important.
Great, thank you. And I think we're at time, so with that, I'd like to thank all of our panelists and speakers, and thank you. Thanks, everyone.